Now let's discuss special triangles or special right triangles. So these triangles are right triangles with some regular feature that makes calculations on the triangle easier, or for which simple formulas exist. So there are three special triangles, three types of special right triangles. So we have the 30, 60, 90 triangles, 45, 45, 90 triangles, and the Pythagorean triple triangles. So in this video, we will discuss the 45, 45, 90 triangle. So this 45, 45, 90 triangle is a special type of isosceles right triangle where the two legs are congruent to one another and the non-right angles are both equal to 45 degrees. So if this is our right triangle, okay, so this is right, then this one is 45 degrees and this one is 45 degrees. So for 45, 45, 90 triangle, the two legs are equal. So this one is equal to this one. And then our hypotenuse is equal to the leg times square root of 2. So the ratio is x is to x is to x square root of 2. Or 1 is to square root of 2. Okay. So now let's try solving some problems here. So we can solve the missing sides by using the Pythagorean theorem or just this formula, the ratio formula. So to solve for the leg, if one of the legs is missing, you just have to divide the hypotenuse. Okay, to solve for the leg given the hypotenuse, you just have to divide the hypotenuse by square root of 2. Okay, and then our hypotenuse is just equal to the leg times square root of 2. Or we can also use the Pythagorean theorem, okay, to solve for the legs and hypotenuse. So C here is the longest side, which is our hypotenuse, and A and B are our legs. Okay, so let's try solving some problems here. So we're given here a right triangle which has a hypotenuse that is equal to 12 and the legs are missing. So let's solve for the legs here. So let's not forget our ratio. X is to x square root of 2. So to solve for the legs, we just have to divide the hypotenuse by square root of 2. So our hypotenuse here is equal to 12. Okay, so our two legs are just equal. So that means x is just equal to y. And to solve for our legs, so x equals y equals the hypotenuse divided by square root of 2. So our hypotenuse is 12, then divide that by square root of 2. So we cannot leave a radical in our denominator, so we need to rationalize this expression by multiplying both our numerator and denominator by square root of 2. So 12 times square root of 2 is just 12 square root of 2. Square root of 2 times square root of 2 is just 2. Then we can simplify this. 12 divided by 2 is 6 square root of 2. So our legs x and y are equal to 6 square root of 2. Now let's try solving this by using the Pythagorean theorem. We'll see if we get the same answers. Okay, so c squared equals a squared plus b squared. Our hypotenuse is 12. So we have the legs. since x is just equal to y, so we can just write x squared plus x squared. 12 squared is 144. And x squared plus x squared is just 2x squared. Divide both sides by 2. So 144 divided by 2 is 72 x squared. So we get the square root of 72 here. So x is just equal to the square root of 72. And we can write 72 as, we can write 72 as 36 times 2. And 36 is a perfect square. So that is x squared of 36 times square root of 2. 36 can be written as 6 squared times square root of 2. So x is just equal to 6 square root of 2. Therefore, x is equal to y and equal to 6 square root of 2. So either methods, we will get the same answer. So let's solve another problem here. Okay, in this case, we are given the value of one leg and another leg is missing and the hypotenuse. So let's solve for the other leg and the hypotenuse. Since this is a 45, 45, 90 triangle, therefore the two legs are just equal. So x is equal to x is just equal to 6. So this is also 6. Now to solve for the hypotenuse, we just have to multiply the leg by square root of 2 based on our ratio. So our leg is equal to 6 times square root of 2. Therefore, our hypotenuse is equal to 6 square root of 2. Okay, that's the quickest method to solve for the value of the values of our legs and hypotenuse. You can always use the Pythagorean theorem in case you forget the ratio. So let's try. So y squared, our hypotenuse, and the legs, 6 squared plus 6 squared. So this is 36 plus 36. So y squared is just equal to, this is 36 plus 36 is 72. Then we square root both sides. So y is just equal to the square root of 72. And then we can write 72 as 36 times 2. And then we can write 36 as 6 squared times square root of 2. Therefore, y is just equal to 6 square root of 2. So our hypotenuse is equal to 6 square root of 2. Okay, let's solve more problems here. So we're given here a triangle where the hypotenuse is given and the two legs are missing. So let's solve for the two legs. Okay, so x is just equal to y. So to solve for the legs, that would be x equals y equals, should be hypotenuse divided by square root of 2. Okay. So that would be equal to 7 square root of 2 over square root of 2. Then the square root of 2 cancels out. So we are left with 7. Therefore, x and y are equal to 7. So both our legs are equal to 7. Again, you can always use the Pythagorean theorem. So we'll see if the legs are equal to 7. So our hypotenuse, 7 square root of 2 squared plus, equals x squared plus y squared. And take note that x is just equal to y. Therefore, we can write this as x squared plus x squared. 7 square root of 2 squared is just 49 times 2. 49 times 2 is just equal to 2x squared. We can divide both sides by 2. This cancels out. So 49 is equal to x squared. Then we get the square root. Square root of 49 is 7. Therefore, our x is equal to 7. So the same answer. Okay, one more problem here. Okay, so we're given here one of the legs, the value of one of the legs, and the other leg is missing, as well as the hypotenuse. So let's solve that. So x is just equal to 4 square root of 3. Okay, let's not forget the ratio for 45, 45, 90 triangle. So to solve for our hypotenuse y, so we just have to multiply the leg by square root of 2. So that is 4 square root of 2, 4 square root of 3, our leg, times square root of 2. So this is 4 square root of 3 times square root of 2 is square root of 6. Therefore, our hypotenuse is just equal to 4 square root of 6, and this one is 4 square root of 3. Again, we can use the Pythagorean theorem. Let's see. So that is y squared equals x squared plus 4 square root of 3 squared. Since x is just equal to 4 square root of 3, then we can write this as 4 square root of 3 squared plus 4 square root of 3 squared. So this is 16 times 3 plus 16 times 3, 48. 16 times 3. Okay, that is 48. Okay, so 48 plus 48 is just 96. Then we get the square root of that. Then 96 can be written as 32 times 3. So y is just equal to the square root of 32 times 3, and 32 can be written as 16 times 2. So 16 times 2 times 3. Okay. So y is equal to the square root of 16 times 2 times 3. 16 is a perfect square, so we can write 16 as 4 squared times 2 times 3. So y would be equal to 4 square root of 6, because 2 times 3 is 6. So we get the same answer for both methods.